Let's discuss the airline referral prediction project. The data set span from 2006 to 2019. There are columns for ratings, review, and categorical information about different airlines. Our main objective is to predict if customer recommend the airline or not. So let's start the coding part. I will use this library that are NumPy, Pandas, Matplotlib, Seaborn, etc. for further analyzing. Let's load our data from the Google Drive. We can see here the top 10 rows from our data set. There are approx 1.30 lakhs rows and 17 columns in our data set. Also, we can see here there are two types data, object and float. There are approx 70,000 duplicate row. Let's remove these rows from our data set. After removing duplicate rows, we have 61,000 rows approx and 17 columns. Let's check the missing value. In every column, at least one row with any values and missing values. The maximum number of any value are in aircraft column. Let's define the function to visualize missing data into chart or to check percentage of missing value in each columns. As you can see, there are 69% missing values in our data set in column of aircraft. Okay, so let's know our data set. The data set has a total of, our original data set has a total of approx 1.30 lakhs and row. It consists of 17 columns. There are both numeric and non-numeric data types in the data set. Okay, let's understand our variables. I am using .keys method. I also can use .column method to check the column name. Let's describe our data set using .describe method. I am using .t method because I want to transpose my table into this format, where you can see the count, mean, standard deviation, minimum value, 25% value, 50%, 75%, and maximum value. Here we can see the date in our data set. There are some missing values. Let's check unique value in each column. In Airline, there are 81 unique values. In overall rating column, there are 10. Major columns are in categorical column. Here you can see seat comfort, cabin service, food, beverage. These columns are rating columns. Our overall column is dependent on other rating columns. We can see in the next chart or table. This is our y variable. We will predict this column, where you can see this. In this column there are only two values. If I check in our data by .head method, so you can see here in overall column, recommended column, there are none value, there are yes and no. Okay, so we have yes or no value in recommended column. Yes mean the customer refer the airline to their friend. So our main objective is to predict whether a customer refer the airline or not. Okay, so I give here a description for each column. The airline, this column contains the name of the airline, and there are 81 unique airline in the dataset. It is of object data type, that is string. Overall is a rating column. The values are in ranges from 1 to 10. The mean overall rating is approx 5.16 with a standard deviation of about 3.48. It is a float type. An author column is not useful for us. In the author column, it contains the name of author who wrote the reviews, and review date is the date column. This column indicates the date of when the review was posted. Okay, and here you can see aircraft where approx 2100 unique aircraft in our dataset. There are 4 type of traveler and 4 type of cabin. Okay, so we will analyze this data. Let's move to data wrangling part. I am replacing the value yes and no into 1 and 0 because I want to train my model in machine language. Machine can easily understand the byte, or we can say 01 language. So I am converting this column into numeric column. This is our y variable. Let's group by overall column. So here you can see minimum value is 1 and maximum is 10. This is rating, overall rating column. And we also see here when other rating are increasing, then overall rating also is increasing, and the recommended mean value also increases. That means our overall variable is dependent on the other rating columns. So we can remove this column because as we can see above in the missing value table, we have ground service rating type column, food beverage entertainment. These are rating columns. So if we give this column into our model, then the model maybe give false result. So we will remove this column because we already have overall rating column. So as seen in the table above, the overall rating increasing when the other rating increase. The overall column is a strong correlation with the other rating columns and the recommended column. Okay, let's define the function to check the mean of recommended and overall in each category. Here you can see in the table, and traveler type business class. So here I am dropping the rows where any and missing value in all columns. So we have only one row where any and none value in all columns. Okay, let's define the list of low null value and high null value, because we will replace low null value with mean. Let's define the function for replacing the any value. Okay, let's check table of airlines. Here you can see the top 4 airlines are Spirit Airlines, American Airlines, United Airlines and British Airways. Let's visualize our data into chart. As we can see in the chart, solo type travel are most traveler. In this chart, on the graph, on the basis of this graph, economic class has the highest recommendation with bad reviews. 0 is for bad reviews and 1 is for good review. Business class has second most recommended cabin type with good reviews. Also, we can see the chart traveler type wise. Solo traveler are the most traveler in our data. Yes, traveling type of solo leisure worth of money compared to other type of traveling. In this chart, we can see cabin wise segregation. Okay, here we can see top 10 airlines. We observed that the top 10 airlines with most trips are Spirit Airline, American Airlines, United Airlines. These are the airlines in top 10. From the above plot, in economic class, the average rating of food, beverage and entertainment given by passenger is lowest as compared to other cabin class. We can see here the chart of different rating columns. The plot reveals several interesting patterns in the feature rating. The overall feature rating of 1 to 2 are the most frequent, suggesting a prevalence of lower rating among passenger. In terms of seat comfort, a rating of 1 is the most common, followed by a rating of 4 as the second highest. For the food and beverage, feature rating of 2, 4 and 5 occur with a roughly equal frequency, indicating a more balanced distribution. So these are the observation from this graph. Let's check the relation between each variable. So here we can see the recommended is highly related with overall. Okay, let's create our DF to train our model. I am assigning these by removing this column and creating a new DF, that is clean underscore DF. We will use this data set in our modeling part. Let's remove NA in our clean data set. I remove NA value and some column that are not relevant to training the model. Rating column other than overall are highly dependent on the overall rating, and some rating column have a high number of missing NA values. Instead of removing NA value, we opted to remove those columns. Let's create X and Y variable. Our Y variable is recommended column and X column is other than recommended column. Okay, so I am transforming my categorical column into different numeric column for better prediction. Let's check after transforming column. Let's check the shape of our data set. As you can see, there are approx 59,000 rows and 86 columns in our data set. The percentage of no label of target variable is 52%. The percentage of yes label of target variable is 48%. Let's split our data into train and test. I am splitting in the ratio of 75 to 25. Our our train data set is 75% of overall data set and 25% is in test data set. Selecting this ratio, I am selecting this ratio because it is a common practice. Let's train our first model, which is logistic regression. As you can see here, of this model, accuracy of this model is approx 95%. Okay, let's train our other model, that is decision tree classifier. Here you can see the accuracy of this model is almost 95%, and we also train our random forest model, where you can see the accuracy of this model is also 95%. Our fourth model is k nearest neighbor. The accuracy of this model is 95 again. And fifth model is support vector machine, where also you can see the accuracy of this model is 95%. Our last model is navy wise classifier. This is the lowest accuracy in this model. Let's compare these model. Okay, so here you can see the logistic regression is the top model for prediction, or we can say decision tree is also almost in these modeling there are 95% accuracy. Okay, we can't use this model because this is the lowest accuracy of modeling. Let's visualize into chart this compare. In the last I give some conclusion for the dataset. Our original dataset have 1.30 lakhs rows approx and 17 column. We removed approx 70,000 rows and we train our model in the ratio of 75 to 25. This is the project of our airline.